Today's lesson is on Objective 8.8, and in this lesson we'll be talking about statistical graphs. And so again, you're going to need your TI Inspire to follow along with what we're going to do today, because we're going to talk about graphs that you can create using your calculator. And we'll talk a little bit about how to interpret those graphs and what they mean. So if you don't have your TI Inspire, go ahead and pause the video for a moment and get it out so that you have it available and you can follow along with the steps I'm going to show you. So if you look at the Objective 8.8 guided notes, you see that we've been given a set of data that represents a student's scores on a history exam. Okay? So one exam, the teacher's looking at the scores, and these are the scores that the students have earned. So we want to be able to analyze these scores. And so to do that, again, we're going to need a way to put these scores into the calculator first, so we can then analyze and look at the kind of results we've gotten. So we want to start again with a new document. Okay, and we're going to again choose our lists and spreadsheet number 4 so that we can add data in. And we're going to start off by naming our column. So let's name this history. Okay, and if we do our down arrow, we're in our first cell to add in our data. So let's go ahead and put our data in. We've got a score of 68, 72, 76, 81, 84, 86. 86 happens 3 times, so we want to put it in 3 times. Then we have an 89, a 91, a 95, and a 99. So we have 12 cells that have been filled in. We can do a quick check and count up to make sure that we have 12 scores in our data to make sure we haven't missed anything. And again, the first type of analysis we can do are those measures of center and measures of dispersion. So if we want to just see what kinds of measures we get, remember to keep your highlighted cell here in column A, and then go Menu, Statistics, Stat Calculations, One Variable Statistics. We have one list. We want the list to be from column A. We want our results to start in column B, and so we hit OK. All right. So our mean for this data is right around 84. That's the average. We have a standard deviation that's about 8.7 right here. 12 scores. Our minimum score was a 68. Our maximum score was a 99. Our median score was an 86. And then again we have that Q1X and Q3X. We're actually going to see what those are all about today, but we'll leave that for just a minute. And so those are our general measures for this data. Okay? But what we're also interested in is how the data looks. And in order to see how it looks, we have different types of graphs that we can use. So in order to get graphs, we're going to need another page. So we're coming over here to our calculator, and I want to do a Control Doc, because you'll notice that in blue above this Doc button it says plus page. So this is going to add a page to this document, which means all of this data that I've entered is still accessible and can still be used, but we're going to use it on another page where we can do something with it. So Control Doc, and we get the list again. What kind of page do we want? Well, this time we want a data and statistics page. So we're going to choose number 5. And you can see all of these dots are just sort of randomly sitting out here. Okay? We can also see that there is a box down at the bottom where if you put your cursor over it, it says to click to add a variable. So with your cursor down in that box, click on it, and you'll notice that the choice of history comes up. You only have one choice here because you only have one column of data in the spreadsheet from the first page. So choose history and notice what happens. So this is what is called a dot plot. This is the first type of graph that we can use. And a dot plot is fairly simple. You have a single number line as your axis. The number line is labeled in a way that is going to include all of your different data points. And then you put a dot above the corresponding number on the number line. So for example, when I hover my cursor over this first dot, it turns into a hand instead of a cursor, and you can see that it's a dot that represents a score of 68. You can also see on the number line, since every tick mark is going by 2, that this would be a score of 68. And you can do that with any of these dots. If you hover over it, it will show you the score as well as noticing the position of your score. Now, most of the scores only happened once, but 86 happened 3 times. So you can see how the dots are getting stacked on top of 86 to show that 86 was a score that was earned on 3 different exams. Okay, and then we've got more scores up here that we can look at. And this just gives us kind of a visual of how the scores have ended up. We can see a bit of the spread from 68 up here to 99. We can see if there are any scores that happened more often than other scores. If there were more scores in here that happened more often, we might get more of a curve kind of thing, and so we can see kind of that shape of what's happening. Okay, excuse me. But what we need to recognize is that in a dot plot, we still have a visual of where every single individual score is. Each one of these dots represents a single score, and we can see how those scores end up, how much they're spread, where we have multiple scores, things like that. Okay, so that's our dot plot. Why don't you go ahead and pause the video for a moment, and in the space on your note sheet, just write down your own description, or maybe draw yourself a little table or a little diagram of what a dot plot is. You see in parentheses there X plot. Back before we had fancy calculators that would do this for us, this used to be called an X plot, because if you did it by hand, most people would use X's to represent each score. So I just threw that in there, that in some books they may still call it an X plot, but most of the time you see it called a dot plot these days. So go ahead and pause the video for a moment, write in an explanation or draw yourself a diagram of what a dot plot is, and then come back and we'll continue with a box and whisker plot. All right, so we've taken a look at our dot plot with all of our individual scores. Now we want to take another look at this from a little different way with a box and whisker plot, or sometimes just called a box plot. And so to get that, we're going to go to our menu. And you'll notice now one of my choices is plot type. When I hover over plot type, you see that dot plot is kind of grayed out. That's because I currently already have the dot plot showing. So it's not a choice, I already have it. So my 2 choices here are the box plot, the box plot and the histogram. Okay, we're not going to worry about normal probability plot for right now, so we're just interested in the box plot and the histogram. So let's do the box plot. Okay, Now we see a very different kind of representation. This is called the box and whisker plot sometimes because you have the box here in the middle, and then you have these lines that extend out from it, kind of like whiskers. Okay, so sometimes it's called a box and whisker plot, sometimes it's just called a box plot. But what this shows us is very different than what the dot plot showed us. For example, on first glance here, you'll notice I don't see individual test scores anymore. They're still here, they're still being represented, but I don't see those individual scores anymore. Now you can, if you click on a particular section here, the dots will show up and you can see more of the individual scores. But even then, when you get like to 86 here, you don't see that there's 3 of them. You just see that there's a score of 86. If you click on those sections again, they'll go away. Okay? Now, what this does show us is the minimum. So when I hover down here on this end of the whisker, I can still see that 68 is my minimum value. I can hover over here and still see that 99 is my maximum value. So the ends of the whiskers still represent the minimum and maximum scores. Now, this box, you'll notice as I hover around, things change a little bit. So let's start with what we know. This middle line down the box is the median. So we saw from our first page that our median score was an 86. Okay, so on our box plot, that's this line right here. That line is always going to be at the median. So it represents the halfway mark of the scores. Half of the scores are on the left side of that line, and half of the scores are on the right side of that line. Okay, the edges of the box represent the median of that half. So if you just go with this first half up to the median, if I took the median again of just that half, I would get this number of 78.5. If I took the median of just this second half, then I would get this number of 90. And so what these values do, these values cut my data into fourths. So a fourth of my data is on this whisker, a fourth of my data is in this first portion of the box, a fourth of my data is in this second portion, and a fourth of my data is on this second whisker. And so since these numbers divide my data into fourths, these are called the quartiles. Q-U-A-R-T-I-L-E, quartile. And quart is a root that means 4, and so we can see how this number is a quartile and this number is a quartile because it's dividing my data into 4s. Okay, so on your note sheet you see a lower quartile. That's also sometimes called the first quartile, which is why we have that Q1 notation. So in this case, the Q1 is 78.5, and the Q3, because Q2 technically is the middle, and that's already called the median, so Q3 is the 90 right here, which is also sometimes called the upper quartile. Okay? And again, if we go back to our analysis here, that's what the Q1, 78.5, and the Q3 of 90 was telling us back in this analysis. So if you were drawing this yourself, you would start by drawing a line at the median of 86, then you would draw lines at 78.5 and at 90 to represent the edges of your box, and then you would create a box with a line at 86 in the middle of it. And then from 78.5 to 68 you would draw a whisker, and from 90 to 99 you would draw a whisker. And that's how we get a graph that looks like this. Okay? Now, even though we don't see the individual scores anymore, this can still be a very helpful graph because now we can see where half of the scores ended up. This box represents the middle half of all of the scores. This is the lower fourth. This represents the upper fourth. So it can be very helpful to see just how spread out that space is for the middle half. Is everybody kind of clumping together, or is it more spread out? We can also see just from the overall length of the whiskers, the box altogether, just how spread out our data is. So we can still get a pretty good feel for range and for spread, even though we're not seeing the individual scores anymore. But it's interesting to be able to see kind of what's happening with that middle 50%. Where is that? Between what scores? How spread out is it? How big is that box? Those are the kinds of things that a box and whisker plot can show you. So again, take a minute to pause the video and write down in your own words what a box and whisker plot is. Or again, draw a diagram if that's helpful and label it with what you need to know. All right, so our third graph is the histogram. Now, if you were doing a histogram by hand, you would first have to go through the process of making what's called a frequency distribution table. Okay, and so a frequency distribution table is a way of taking the data that you're given and organizing it a bit so that you know what each bar of your histogram should represent. Okay, so you need kind of a little bit of a plan before you make the histogram, especially if you were doing this by hand. But even on the calculator, if I just go to the histogram right now as my third option, it's going to choose to show it in a way that the calculator decides to show it, which may not be congruent with what I want it to show. So it helps to make a frequency distribution table first so that we kind of know what do we want each interval to be, what should each bar represent, and then how many scores are actually in that interval. So the way to do that is to take our data, okay, and we're going to take the range of this data. So the 99 minus the 68 gives us a range of 31. Okay, and then we want to take that 31, because that's the spread here, that's the range of our scores, and we want to decide how many intervals, how many bars do I actually want. So based on the way this table is set up, we have room for 4 sections. So we're going to take our 31 and we're going to divide it by 4. So 31 divided by 4, that's going to go 7 times, which gives me 28, and leaves me with a remainder of 3. So I technically get 7 3/4. But obviously I don't want my intervals to go to fractions or decimals, so I'm going to round up. And the reason I usually want to round up is because I want to make sure all of my intervals will contain all of my values. Okay? If I round down to a 7, then there's a good chance that not everything is going to be included in the bars that I set up. So we usually want to round up to make sure that everything gets included. Okay, so my first interval then is going to start at 68 because that's my lowest number. And then we're going to go 8. So 68 counts as our first one. Okay, 69, 70, 71, 72, 73, 74, 75. So this is actually going to go up to 75. Now that seems weird because it looks like it's an interval of 7. But it's not, because 68 is going to be included. So it really is an interval of 8. Okay, and then 76 is where we'll start our next interval, because 75 was already included in this first interval. Okay, so again, 76, 77, 78, 79, 80, 81, 82, 83. So this one's going to go up to an 83. This one will start with an 84. That will go up to a 91. Sorry, 91. There we go. And then this will start with a 92. And we'll go up to a 99. Okay, and so 68 being my minimum value and 99 being my maximum value, everything fits. This first interval will include the 68. This last interval will include the 99. Everything is going to fit. So now I go through, and for every score, I make a tally in the interval it belongs. So 68 belongs in that interval. 72 also belongs in that interval. 76, that moves up to this next interval because 76 is the beginning of that interval. 81, also in this interval. 84 moves up to our third interval. 86 is also in the third interval and happens 3 times. 89, still in the third interval. 91 is still in the third interval. 95 moves up to our fourth interval, and 99 is in our fourth interval. So for every score in your data, you make a mark in the appropriate interval for it. And then here in the frequency column, you actually write how many tick marks you end up with. So we end up with 2, 2, 6, and 2. Okay, so now this is what we want our histogram to show us. We want our histogram to have bars, which are 4 bars representing an interval of 8, and we want each bar to represent this number. So the first 2 bars should be 2, the third bar is 6, and then the fourth bar 2. All right, so let's go back to our graph. Whoops, wrong way, sorry. So now if I go to the menu and I go back to plot type and I choose histogram this time, okay, we can see now how we get these bars. And what's unique about a histogram compared to just a bar graph is that when we have scores next to each other, the bars are actually next to each other. There's no space between bars that are consecutive. Okay, so as you can see here, these 3 bars are all right next to each other because we don't want there to be an impression that there's a break in our number line. Okay, this bar represents everything from, and you can see there, from 81 up to but not including 83. So the bracket beside the 81 tells us 81 is included. The parenthesis that is beside the 83 tells us 83 is not included. And if I hover over the next bar, you'll see that 83 is the first included value in that next bar. So it's all continuous. This bar represents everything up to 83, and then this bar represents 83 and everything up to 85, and then this bar represents everything from 85 up to 87. Okay, but this is not the way we've set up our distribution. This is not what we're looking for. So we want to be able to change this to what we want, which is 4 bars, each bar representing an interval of 8 8 score points. Okay, so to do that, we're going to go to our menu again, and this time instead of plot type, we're going to go to plot properties. and we have a choice for histogram properties. Now follow this because there's a lot of, this one's a deep one, okay? So we're going plot properties, we go to histogram properties, okay? We've got a choice of histogram scale or bin settings. Bin is what the TI calls their bars. Okay, so bin settings is what we want because we want to adjust the bars. Okay, and in the bin settings we want equal bin width. We don't want them to change. We want all of the bars to be the same interval. Okay, so let's follow that one more time because that one's a deep one. Menu, plot properties, histogram properties, bin settings, equal bin width. Okay? When we click on that, there are two things that we can adjust. The first is the width itself. We want to have a width of, let's see, how come mine's not, hopefully it'll go, of 8, correct? That's what we decided from our calculation. That's how we set up our intervals. So we want a width of 8. The alignment is basically the number that we want to start at. So if I click on alignment, I want to start with the first quiz score, of 68. Okay, so starting at 68 with a width of 8. Let's see if we get what we want. Okay, so it's looking pretty good. We've got our 4 bars here. One of the things you notice is that this bar now seems to run off of our graph. And I don't want that. I want to be able to see what's going on. So you can adjust that by coming over here to your vertical axis and see how when I move over just to the left of the axis I get a little bit of a change in my cursor. Okay, do a control click, okay, and get the hand that kind of grabs it, and then scroll down. Use your down arrow, move that down, and then when you just click again, it'll let go. But that moves it down now so that we can actually see how high this bar is going, which is to 6. That seems good. So we've got 2, 2, 6, and 2. That's what we wanted. And when I hover over this first bar, at first glance it looks like the bar is incorrect because it looks like it's going from 68 to 76. But it's really not, because again, the bracket beside the 68 tells me that that's included, but the parentheses beside the 76 tells me that's not included. So this really is a bar that is showing me scores from 68 up to but not including 76. So it's really only going up to 75 or 75.5 or 75.99 if we had scores like that. And when I then move to the next bar to the right, now notice that 76 becomes the first number of that bar with the bracket to represent that 76 is actually a part of this bar. Okay, so we now have what our frequency distribution table set up for us. 4 bars with the correct intervals of 8, 2, 2, 6, and 2. Now again, there are advantages and disadvantages. One of the disadvantages of a histogram is that we no longer see the individual scores at all. Even if I click on any one of these, I don't see any individual scores. What we see are clumps. Okay, each bar represents a clump or an interval of scores. But even that can be helpful sometimes to be able to see what kind of shape those bars take. For example, it looks like a lot of students ended up right here in the 84 to 92 range compared to the other intervals. So that gives us an idea of where most of the students seem to have fallen. Especially when you're talking about grades, it would make sense to maybe set up your bars so that they went from 60 to 70 and then 70 to 80, since that's what the letter grades correspond with. And then you'd be able to very easily tell how many students got each grade. Okay, so there are some uses for a histogram. They can be helpful at times depending on what it is you're trying to demonstrate or what it is you're trying to interpret from your information. But we again need to understand there are certain limitations as well. I cannot tell you exactly what the scores were anymore by looking at this histogram. Okay, so that is going to do it for today. When you finish this video, I would suggest you take a moment and write in an explanation or draw a diagram for the histogram as the final piece of your notes. And then when you go to your 8.8 practice today, you're going to be practicing setting this up. So you have 2 sets of data. One is for NCAA men's basketball tournament in the United States, and one's for the National Invitational Tournament. And you're going to be using that and making some comparisons. And one thing I want to show you really quick that might be helpful. If we put in a second set of data here, let me call this math scores. Okay, I'm just going to make up some scores here quick. 58, 92, 87, 95, 88, 89, 91, 65, 98. Okay? So I have another set of data here in another column. I'm going to add another page here just to show you what you can do. So we're going to go Data and Statistics again. Okay, and then I can compare 2 different sets of data on the same screen by splitting up my screen. And the way to do that is to go to your menu. Oh, I'm sorry, it's not menu. Hit escape. It's your dock. Okay, in the dock button you have a choice of page layout. So if you select the layout, one of them, layout 3, allows you to split the screen so that you have something on top and something on the bottom. This is a really good layout for graphs. So choose layout 3, and now you can see that right now the border around the top part, see how there's that black border? That means this is the screen that's chosen. So I can work with this screen, and let's say I want this again to represent the history scores. I'm just going to do a dot plot. Okay, the dot plot is always the default when you do this. And then if you want something else, you go to the menu and you change it. But I want to compare that to the math scores. So when I click down here for press menu, it's going to ask me, well, what kind of screen do you want this to be? I want it to be Data and Statistics also. But this time I want it to represent the math scores. Okay, and so now you can start making some comparisons because they're both here on the same screen. So I can look at history scores, I can look at math scores, I can make some analysis about how bunched together they are, I can look at whether scores seem to be higher or lower in one or the other. One of the things you have to be careful about though is scale. Notice that this scale is going from 66 up to 100. This scale goes from 55 up to 100. So if you're making comparisons based on the dots right now, it may be deceiving because it may look like these 2 dots are both here at about the same place, and therefore they both had about the same lowest score. Now, that's not true. This was a 68 for the lowest score, and this is a 58 for the lowest score. So one of the things you want to consider is that scale. And I'm going to click back up in this window, and I'm going to adjust this scale so that it matches. So again, I come down here to where my scale is. I do a control click, and then I just move it to the right until I get that 55 to show up. Okay, now I have a scale from 55 to 100, just like I have down here. Now the comparisons are going to be more accurate. Okay, so you're going to get to a point in the practice where it's going to ask you to split screens like this and make some comparisons. If you didn't quite catch all that, rewind, watch it one more time, or come back to it when you need to in the practice and watch it one more time. Okay, but this is really nice for making comparisons, to be able to look at both graphs on the same page. Okay, so that should do it for today. Hope that helps you with your practice, and if you have any major questions, make sure you let me know or get the help that you need there in Hanoi, and we will see you next lesson.